Hello everyone. Today we would like to present our group project entitled A Relation Between Mouth Volume with Sex, Age, Height and Weight. We are from group 7, section 4. By introducing our project, the different variation of human body structure plays many important roles across many fields. We analyzed a specialized anthropometric dataset consisting of 61 human subjects with the five key variables, which are mouth volume, age, sex, height, and weight. We also use blend of continuous and categorical data here. Next, moving on to the data analysis part, I would like to explain about hypothesis testing with two samples. So for this part of analysis, our goal is to determine if there is any significant difference between mean mouth volume of females and males. So we let mean 1 equal to mean mouth volume of females and the mean 2 is for males. So the hypothesis statement here is for the null hypothesis, we decide to put mean 1 equal to mean 2 and the alternative hypothesis is mean 1 is not equal to mean 2 with the significance level at 0.05. For the calculation part, t value we have calculated 3.0493 by using the formula and p value we got 0.003432. By concluding the hypothesis testing, since we don't know the value of variance for the both samples, so we conduct an independent two-sample t-test to compare the mouth volumes between two biological sexes. So due to the sample sizes are being too big, which is n1 equal to 30 and n2 equal to 31, we assume that this sample is normally distributed. And the analysis is two-tailed test. Based on the values that retrieved from R, our p-value is less than the significance level, which is 0.003432 is less than 0.05. This will lead to the rejection of null hypothesis. So from this information, we can conclude that there is significant difference in average mouth volume between biological sexes. Specifically, on average, men has significantly larger mouth volume with the value 66.35 compared to female, which they only have 53.99 units on average.
I am Nur Alia Wafa and I will continue with the data analysis for the second analysis that we do, which is correlation analysis. In this correlation analysis, the variable that we use are height in cm and weight in kg. Our goal is to identify whether there is a significant linear relationship between height and weight using the Pearson product moment correlation coefficient at 5% level of significance. So for the hypothesis statement, for the null hypothesis, we have rho equal to 0, which means there is no linear correlation while alternative hypothesis is rho is not equal to 0, meaning that linear correlation is exists between the height and weight. So significance level that we use is alpha equals to 0.05. So here we have the t-test. We use t-test value and got 5.1274, and from that we using the R to get the p-value, which is 0.00000342. So then using the information, our data, we draw the scatter plot using the R. So based on the scatter plot, there is moderately positive linear relationship between the height and weight. As height increases, weight tends to increase predictably. The data points placed along the upward sloping trend line, indicating that a subject height is a reliable indicator of their overall body weight within this sample population. Through the result of scatter plot graph and the correlation test, from the correlation test we got that p-value is less than the significant level, which is 0.005. So we tend to reject the null hypothesis. It is shown that the height is significantly correlated with the weight because they share a positive linear dynamic. When height increased, the weight increased. It means someone with taller height generally has a heavier weight. Continue with the regression analysis. So the variable that we use for this analysis are mouth volume and weight of the 61 human subjects. As we only use one independent variable, we are using simple regression to find the linear regression model. Through the test, our main objective is to determine if subject weight can significantly predict their mouth volume using a simple linear regression model at a 5% level of significance. So the following is the scatter plot of mouth volume against weight. This equation is to find the line for the graph previous. So this is the equation that we use. Based on the plot, this is including line which shows a moderate linear relationship between the independent and dependent variable. Through analysis, we obtain the value of intersection coefficient is 28.3435 and value of estimated change in average mouth volume is 0.4334. The estimated regression model is as follows, which is y hat equal to 28.3435 plus 0.4334 times x. So 28.3435 is the intercept, while 0.4334 is the value of the slope. And then from the equation, we also need to find the R square for the regression analysis. So we need to find SST, SSR, and SSE. And then for the R square, we got 0.1950. So this value is uh, explained that 19.5% variance in mouth volume can be explained by weight alone for this sample, while the remaining can be explained by other traits. In this test, our hypothesis statement is beta 1 equals to 0, which means nonlinear relationship between x and y value. And alternative hypothesis, which is beta 1, is not equal to 0. Uh, there is a linear relationship between the mouth volume and weight. Then we calculate the t-test and got 3.7818 and p-value using the r we got 0.000367. So the conclusion is since p-value is less than significance level which is 0.005, null hypothesis is rejected. Therefore, we can conclude that there exists a linear relationship between mouth volume y and weight x. That's all.
Hi, my name is Ili Amira, and I'll be presenting my part for data analysis, which is the chi-square test of independence. As you can see here, the test is used to determine whether there exists a statistically significant relationship between the two variables, which are sex and mouth volume. Based on the calculation, we receive that the median value for mouth volume is 57.277, and these will serve as our benchmark to classify the data into two different groups, which are low volume and high volume. As you can see here, for male sex, there exists 21 out of 31 that falls into high volume group. As for females, there's only 10 out of 30 that falls into the same group. Here, we can see that male are more likely to have a larger mouth volume compared to women. So, we can justify and conclude that sex and mouth volume depend on each other. As you can see here, this is the work steps for us to justify our hypothesis just now. First things first, we have to state the hypothesis statement, which are H null where both variables are independent, while H1 are when both variables are dependent on each other. For chi-square test, we'll be using this specific formula, and we'll just use RStudio to obtain the p-value, which is 0.0072. And as the significant level here is 0.05, we can see that the p-value is less than the significant level. Thus, we reject the null hypothesis. So, we can clearly see there is a sufficient evidence to conclude that sex and mouth volume are both dependent toward each other. See, this actually justify our hypothesis just now. So, we can say that male do have the larger amount of mouth volume compared to female. So biological sex appears to influence the mouth volume. And that's all for chi-square method. This project helped us to see in detail how this analysis method have their own differences and when will we be able to use it. And we also learned the correct way to use RStudio and also Excel. Here we can conclude that all gender, sex, height, and weight can influence the mouth volume, and they also might influence each other. So, that's all from us. Thank you for your time and attention.